Saul, thanks so much for being here today. You're a world-renowned number theorist, a fellow in the American Mathematical Society. You're the James P. McIntyre Professor of Mathematics at Boston College and Department Chair at Boston College. With all of your work in mathematics, you've also been a very strong advocate for Common Core state standards in mathematics. You've written a number of op-ed pieces, including a piece for USA Today. So what is it about the Common Core state standards for mathematics that makes you such a supporter?
When I started out being interested in math education, it was right in the middle of the math wars. And there was a tremendous negative dynamic involving mathematicians and educators who really did not agree at all, and lots of ideas out there for how to teach things that maybe weren't really so well founded in the long run. But now things are different. Now mathematicians and math educators and teachers are all talking together, and there's a broad agreement. Our curriculum used to be a mile wide and an inch deep. With Common Core, we have a chance to focus on what's important and develop the deep content knowledge that children need to use the material, not just 1 year, but in years to come. It's simply such a strong product that I think supporting it is a no-brainer. And I think that we need to work together to take this wonderful list of topics and figure out how to communicate it to every child in this country effectively so that every child has the opportunity to succeed in mathematics and science and technology and engineering.
So why is having fewer topics and more focus important? Isn't that dumbing down the curriculum?
You know, in the old days, children would learn a little bit about a lot of topics and then revisit them each year and each year and each year. And I think they had to wonder, why do we hear just a tiny bit about all these topics? Isn't there anything more to it? The reality is time in a classroom is limited, but if we focus it the right way, we can build a deeper understanding, an understanding of mathematics as not just procedures, but as ideas and concepts that fit together, and the procedures are supported by underlying aspects of arithmetic and number system or geometry. And using that information, kids will learn mathematics in such a way that they can not just learn it once and then need to learn it the next year, but will learn it once and then have it to unpack and use and develop and strengthen and go beyond the subsequent years. That's the thing that Common Core is offering us. I think that we as a society owe to each child the opportunity to succeed. There are more and more jobs in STEM areas, jobs that require strong math skills, and every child in our society deserves the opportunity to seek out those jobs, to get the skill sets so that when they make choices, that's on the list of possibilities. At the moment, I would say that a lot of things are not working as well as they could in the world of mathematics education. We look at kids going to college and needing remedial instruction. That means they arrive at college but are not ready to take courses that would give them credit towards graduation from college. Even among the ones that don't need remedial work, lots of them take courses that basically cover mathematics that they could learn in high school. I believe that if we implement Common Core well, we will give more kids the chance to succeed in college and to have opportunity to careers that make use of mathematics skills.
What is it specifically about the Common Core state standards that makes you think students going through a curriculum based on them will be better prepared than the students we have now?
Before Common Core, each state had their own standards. Some standards made a lot of sense. The ones in Massachusetts are a good example. Some standards probably weren't so well articulated to the needs of students who wanted to possibly go on in science, technology, or engineering. The Common Core standards make sense. They specify what kids should learn, and the kids that do that will have the skill set to go to college and take credit-bearing classes.
It's interesting that you say that, because one of the criticisms of Common Core is that it won't in fact prepare students for calculus or higher level mathematics. How do you respond to critics who make those claims?
Common Core, I think, is a floor, not a ceiling. And that's reasonable as a floor. It's what someone should learn if their interest and their love is totally different from the areas of science and technology, and that makes sense. But students who want to leave options in science, technology, engineering, and mathematics open, of course, need to do more than the floor. So there are extra standards that are called plus standards that are useful for people who want to keep those options open. And I hope the vast majority of our students will choose to pursue mathematics and learn things at the level of those plus standards. Someone who completes the plus standards, I believe, will be well prepared to take calculus in college. And I hope that some students will go on and take calculus in high school. But let's be clear that there's more than one way to learn things. You can learn calculus as a bunch of rules and a bunch of specific types of problems that you learn how to solve. Maybe you can even do well on an exam, but that's not the same thing as knowing it so that you can use it. What Common Core is about, from kindergarten up through the last year of high school, is learning mathematics in a way that enables you to use it, that enables a student to encounter a new problem that they haven't encountered before and to apply the principles and ideas and computational skills that they've developed and work and solve that new problem. That's really what a student needs to succeed in college.
Yeah, I strongly agree with you. I mean, my experience in the Pittsburgh Public Schools had been that we had students who were doing well in some classes and wanted to accelerate, but somehow we're missing the conceptual basis for help them be successful. How do you think as I read Common Core, I see a lot of things in those standards that would in fact build a stronger foundation.
To be effective using mathematics, students need to do two different things. They need to have all the technique. They need to be able to compute fluently and accurately. They need to choose the best method to do a computation, not doing it a slow and elaborate way when there's a trick and a smart way that allows them to get the answer more effectively. But they need to do things and they need to do them right. They also need to understand things. They need to understand why things work the way they are. They need to know some rules, but if they encounter a new situation, they need to be able to figure out for themselves the new rule which would allow them to handle that situation. This isn't my observation. This goes back to Euler, who said the same thing probably 275 years ago, talking about the need to learn mathematics in that generation. So of course the ideas have changed and developed, but the basic principle is the same. Students need computational fluency and the deep conceptual understanding that hopefully accompanies that computational fluency, and they need to be able to bring those both to bear to analyze situations and model situations where mathematics is the way to improve the understanding of those situations.
It's interesting that you cited Euler as the source for that, because more recently, in the past 20 years or so, one of the findings from cognitive science has been the value of having a conceptual understanding is the basis for learning procedures. That when you understand the concepts underlying it, it makes it easier for you to learn the procedures, because you know what to do when you get stuck and forget a step. It makes it easier for you to then retain it. So again, if you don't use it for a while and then you have to go back and reconstruct it, you have a way to do that. And of course, the last thing that you mentioned is it gives you an understanding so you can extend and apply that procedure much later. In particular, I think one of the things that we've been hearing some pushback about at the elementary level is why students aren't just memorizing procedures for things like adding, subtracting, multiplying, dividing.
I think if students can develop understanding of the standard algorithms at the elementary level, they can understand why they multiply multi-digit numbers, for example, the way they do. That understanding will serve them very well when they go off to multiply polynomials as they learn algebra, because they'll recognize that the steps are basically the same. So when we develop good understanding at the elementary level, we give students a fantastic foundation to succeed in algebra. And indeed, it's the students that struggle with algebra who historically have done the worst in terms of their future mathematics and who have had the least access to good careers that may make use of mathematics.